Hello everyone, my name is Nilesh and welcome to the machine learning case study on linear regression. Today I'm going to talk about how we apply machine learning algorithms specifically to linear regression to real data set to predict the prices of the car. Typically we follow a crisp DM framework which starts with understanding the business goal and the problem statement. The problem statement here given for the assignment was Chinese automobile company would aspire to enter the US market. Hence, they would like to understand the independent variables or the factors impacting the prices of the car and how could they remain competitive as compared to the US and the European counterpart. So the goal was required to build a model that could predict the price of the car for those variables. These variables can then be understood by the management to price the car as appropriate. So in short, basically identify the variables affecting the car prices, create a model that could quantify the prices and whether the model is accurate enough. So the next step in this linear regression is data preparation. So typically the data preparation involves ensuring there is no duplicates, outliers, missing values, or variables which are either categorical in nature or continuous in nature. So we have to understand in context of the business problem what do we do with that. We also validate the data set for entries which have very few observations as compared to the observations which could significantly impact those parameters for the prices of the car. So when we build the model, we try to build containing all the variables using the LM model, and then during the building of the model we typically carry all the variables and then splitting the data set into training and the test data set. The next step is to create the derived metrics, that is in multiple variable regression we typically look at the adjusted R-square matrix than the R-square itself. So one of the issues that we face in multiple variable regression is that a multicollinearity. What it means is that there could be other insignificant variables which could impact the prices of the car. So one way to deal with the multicollinearity is the variance inflation factor, the VIF. The higher the VIF, the higher the multicollinearity. So this we have to remove the variable based on the multicollinearity of VIF and P and check the VIF value and the P value. We use the function called the step AIC. So typically we follow the steps as building the model with all the variables, run the step AIC model containing all the variables, taking the last model call for the functions, and then we evaluate the remaining variables. Proceed as we did with the backward, remove all the variables with high VIF and insignificant P value one by one. After removing the insignificant variables, we are typically left with a model which has all the variables which are significant in nature. At the end, we classify this as the final model, and then we test this model by predicting the results from the test data set and evaluating the R-square model between the actuals and the predicted price. We end up with pricing model which could typically help the management in launching themselves into the US or the European market. Thanks for listening. If